Hey, welcome to Hangar Z Podcast. I'm your host, John Gray. Back for episode number 2. I guess it's 1.2 with GPMS, Todd Powers, and Ronnie Ries. How you guys doing?
Doing great.
Really
Thanks.
Yeah, it's good to have you guys. And we got Jeff with us. How you doing, Jeff?
I'm doing well, John. How are you?
I'm good, man. Again, happy to have you guys here. The last couple interviews unintentionally have turned into these conversations that surround technology. And it's really been interesting. I feel like technology is really expanding our capabilities, not just in public safety aviation, but aviation in general. We just had an interview with Shotover, and obviously their technology, the things they're doing there are really making or revolutionizing the things that are happening in law enforcement and public safety in general. I think the technology that you guys are bringing to bear at GPMS with the HUMS technology is going to change the mission effectiveness and readiness state that a lot of agencies struggle with. A lot of agencies have difficulty maintaining their fleet. They might have a small fleet of 1, 2, 3, 4 helicopters, all the way to the LAPD 20 ship style agencies. But that technology that you guys are able to develop and employ, I think will be beneficial for all these public safety agencies to be ready to deploy and ready to go more efficiently. So before we kind of dive into your guys' background, I'd like to kind of lead the conversation. Maybe Ronnie, we could start with you. Can you just talk about GPMS, briefly, and then I'll switch to Todd if you can just kind of describe the HUMS technology and how you guys are pushing that into the field and how that's helping people.
Yeah, absolutely, John. So here at GPMS, we manufacture predictive health and usage monitoring systems that are also integrated with flight data monitoring, exceedance tracking, as well as a way to basically completely optimize your rotor track and balance system, where you almost don't need a RADS or microvibe or Zings anymore, because it's doing everything for you. So the technology that we're doing is certified on a lot of different models, especially within the public safety area of the models that most of your listeners are going to be flying. So on the 407s, on the A-Stars, H125, AS350s, all the way going up to, we're getting certification pretty soon on the UH-68 Blackhawk, right? They're going to be doing a lot of the firefighting out there, especially on the West Coast and globally around the world, that's going on. So from the lightest end of the market all the way to the most heavy things out there, we're really trying to bring this health and use monitoring system to the market, and it's really going to optimize the maintenance and safety of the public safety market. And so we're pretty excited about it, and we're getting some really great interest and getting some good contracts coming in. So
yeah, I don't know a ton about HUMS and the technology behind it, but what I do know, you talked about the predictive health stuff. This technology allows you to kind of get an understanding of the overall engine and hardware health in the ship, to give you an idea of how much time you may have left in some of the components. But the other thing I know is that prior to these recent times, these were available, but only on larger aircraft, at least to my understanding. And you guys are now making that available to the single engine A-Stars, the ships that are being used in law enforcement, the 407s and the 505. And so Todd, on that, can you speak to how that's kind of being pushed out?
So it's basically a way to put almost X-ray vision on, and to be able to look inside the components at the bearing level to the level of the inside race, the outside race of a bearing, and the ball bearings. That's specific, and to the shaft. We're measuring the speed and the vibration frequencies of each of those components. And then when you land, it grabs the cell phone signal when you land on the ground. As soon as you roll to idle, within 2 minutes, it grabs the cell phone signal. It pushes all that stuff up to the cloud, and then it's available to you as the user just by putting in your username and password at any portal that you would get on the internet, and be able to access the information. And it's compared to what the systems used to look like, that were horrifically expensive, horribly heavy, and really not that useful. It's super lightweight, it's super fast, and it gives you access to things that I think are really the biggest blind spot that we have when we're talking about aircraft, what's going on inside the engine right now with components that are spinning at 55,000 RPM. I mean, it's almost unimaginable what's going on inside of a turbine engine or a main rotor gearbox or a tail rotor gearbox or the tail rotor drive shaft bearings that you really never look at until you take it out and send it away and they overhaul it. The mechanics don't tear it into a million pieces every 100 hours. Those components are basically hermetically sealed until the day that they reach their TBAO and go back. And then they come back, and you hope that since it was taken apart and put back together, everything went together perfectly. Probably the highest risk time that I had as a pilot was as a maintenance test pilot, bringing aircraft out of maintenance. You put a new engine in, put a new gearbox in, put new hanger bearings on. That's probably the point that you're going to see most of the failures, because it's had some invasive action taken. And it's not, and I had this with new aircraft, it's not when an aircraft has 2,000 hours on it that you really worry about it, because by then everybody's proven itself over time. It's really when things go into service. And, and then it's the idea of, how are you going to monitor the true health of those components over the long term? Well, you're going to look at chip plugs. You're going to look at oil samples. It's very primitive when you think about it. You're going to wait for a piece of metal to break off, swim around through the oil, hopefully lodge itself on that magnet, which has, by all of the studies I've seen is about a 50% chance, best case, that it's going to catch it. But by that time, it's already an emergency. It's already a repair. You've already done damage. You've already fouled the cooling system for that oil system. You've already created an event that's going to cause out of service time, AOG issues, mechanics going into the field to resolve whatever problem. In an emergency landing, in most flight manuals, a chip light is a land as soon as possible. And in most of the environments we fly around in, over urban areas and at night, that's not the best opportunity for the best outcome. Our system gives you a look at that in the future and says, all right, sometime between now and 200 hours from now, and it's going to give you the time remaining. It'll say, all right, within the next 200 hours, and probably closer to that 200-hour mark, this bearing is going to start to deteriorate to a point where you're going to need to address it in maintenance. So you've suddenly moved from an unscheduled event into a scheduled maintenance event, which takes all the pressure off the maintenance department, takes all the pressure off scheduling, allows you to order parts. You don't pay all those rush counter-to-counter AOG fees. It's one of those places that the industry wants to get to. It's our path to on-condition maintenance rather than these maintenance schedules that are all just based on taking the aircraft apart, because that's the best we knew when they wrote the maintenance cycle for that. And then with that data, you can do a lot of other things.
The first kind of question I have is, so once your system's installed on an aircraft, I'm assuming it takes some time for that software to develop an understanding of what the aircraft normal state is, right?
So not really. So basically, as soon as you have this installed, and we've seen it with some of our aircraft already for some of our customers. In fact, one of them that recently got their aircraft installed, it was a already in service aircraft. They had this come in, they installed the sensors, and then suddenly they saw there were some bearings lighting up in the system. They're like, well, maybe it's the sensor. Well, in reality, it's your real first deep CAT scan MRI of the entire system of things that you can't see, you can't smell, and you don't feel yet, because the component has not gotten to that section yet, right? When you wake up in the morning and you get out of bed, when your back hurts, well, it's because you already did something wrong with it usually. I mean, you get a little older, it happens sometimes, but if you worked out really bad a couple of days before or something like that, you're going to feel it a couple of days later, right? That delay is happening throughout time when you're talking about bearings getting chipped or starting to wear down and so forth. And so other than an oil analysis every single day, multiple times a day, the next best way to monitor the health of bearings and shafts and drive and gears in an aircraft, the next best way is through vibration analysis. And that's what HUMS really brings to the table, is that vibration analysis of basically hearing what's going on all the way down to the part of the bearing, the inner, the outer, the ball, where exactly it is. It gives you that in-depth look into where it is. And so as soon as you start installing it, the first time you turn it on, you may find some stuff that you don't like. But the reality is that stuff was going to come at you, but you didn't know when or how bad. And so basically, like I said, it gives you your in-depth, you went in for your physical. You may not like what you hear about that physical, but the reality is you're going to be a heck of a lot healthier coming out of that physical going forward.